The end of the universe, apocalyptic scenarios. The universe as we know it, with its countless galaxies, stars, planets, and the extraordinary variety of cosmic phenomena, began approximately 13.8 billion years ago with the Big Bang, the primordial explosion that gave rise to time, space, and matter. However, scientists believe that just as the universe had a beginning, it will also have an end. But what will the ultimate fate of the cosmos be? This question has fascinated astronomers, physicists, and philosophers for centuries, and today, thanks to modern cosmological discoveries, we have several scientific models that describe how the universe might end. These scenarios, often referred to as apocalyptic scenarios, range from a slow extinction of the cosmos to catastrophic events of immense violence. Let's now explore the main theoretical models that could outline the end of the universe and their implications. 1. The Big Freeze or heat death. The universe slowly fades away. The Big Freeze, also known as heat death, is perhaps the coldest and most desolate scenario among those hypothesized. This model is based on the idea that the universe will continue to expand indefinitely, with an ever-accelerating expansion driven by the mysterious dark energy, an invisible force pushing galaxies apart at an increasing speed. As the universe expands, stars will slowly burn out as they exhaust their nuclear fuel, and no new stars will form since the gas reserves needed for star formation will also run out. This will lead to a dark universe, where galaxies become ghostly clusters of dead stars, such as white dwarfs, neutron stars, and black holes. Over time, even black holes will evaporate into darkness due to Hawking radiation, leaving behind only scattered subatomic particles. The second law of thermodynamics suggests that, over time, the entropy of the universe will reach its maximum, meaning that no energy will be available to power any physical or life processes. This state of thermal equilibrium represents the ultimate fate of the Big Freeze, a cold, dark, and static universe where nothing happens, no shining stars or forming galaxies. The cosmos will become a vast desert of particles, drifting in the infinite, incapable of interacting with one another. This scenario could unfold over trillions of years, projecting a slow and silent end to our universe. 2. The Big Rip. The universe torn apart. If the Big Freeze represents a slow and cold end, the Big Rip is a far more dramatic scenario. This hypothesis is based on a more aggressive form of dark energy that not only accelerates the universe's expansion but does so at an ever-increasing rate. In this case, the force of expansion would become so powerful that it would literally tear the universe apart, piece by piece. In the Big Rip model, not only would galaxies progressively drift apart, but individual stars, planets, and even atoms would be torn apart. First, the largest structures, such as galaxy clusters, would be destroyed, followed by individual galaxies, stars, planets, and finally, molecules and atoms. In the final stage, even the subatomic particles that make up matter would disintegrate, dissolving into pure energy. This could happen over a relatively short time compared to other scenarios, possibly within billions of years or less. The Big Rip would be a violent and rapid cosmic event, tearing the universe apart in every way, leaving behind an empty and desolate space. It's one of the most unsettling hypotheses, as not only everything we know would be destroyed, but even the laws of physics could be altered in the final phase. 3. The Big Crunch. The collapsing universe. While the Big Freeze and Big Rip are based on an infinitely expanding universe, the Big Crunch is a hypothesis that predicts the reversal of expansion. In this scenario, after a long period of expansion, the gravitational attraction between galaxies would eventually overcome the expansion, and the universe would slowly begin to contract upon itself. This contraction could culminate in a catastrophic event where all galaxies, stars, and planets would progressively collapse into a singular point, similar to the one that gave rise to the Big Bang. Temperatures would rise drastically as matter is compressed, and eventually, everything that exists would be crushed into a single, dense singularity. The Big Crunch can be seen as a return to the origins, a cosmic cycle that ends as it began, with a singular point of infinite density and temperature. However, the latest observations on the accelerated expansion of the universe, driven by dark energy, make this scenario less likely than others, at least based on current knowledge. 4. The Big Bounce, a cyclical universe. The Big Bounce offers a more optimistic perspective compared to the Big Crunch, suggesting that the collapse of the universe might not be the final end, but merely a transition phase toward a new cycle of expansion. In this theory, after the universe collapses into a singularity through the Big Crunch, a new Big Bang could occur, giving rise to a new cosmic cycle. This model hypothesizes that the universe could be cyclical, going through infinite phases of expansion and contraction, where each bounce marks the end of one universe and the beginning of another. This theory finds support in some interpretations of quantum gravity, which attempt to describe the behavior of spacetime on a microscopic scale. Although the Big Bounce remains speculative, it has the appeal of avoiding a final fate for the universe, replacing it with an infinite series of cosmic rebirths. 5. Vacuum decay, a quantum collapse. One of the most exotic scenarios is vacuum decay, derived from quantum physics. According to this theory, we live in a state known as a false vacuum, which is stable but not the only possible state. In other words, our universe might exist in a condition of temporary stability, and a sudden shift in the quantum vacuum state could trigger a collapse. If this happened, a bubble of true vacuum would form and expand at the speed of light, annihilating everything it encounters. This quantum collapse would destroy everything, including the laws of physics as we know them. Since this bubble would move at the speed of light, no one would be aware of its expansion until it was too late. This scenario is extremely speculative, but it's considered a real possibility within the framework of quantum field theory. Which scenario is most likely? Current observations of the universe suggest that its expansion is accelerating, pointing to scenarios like the Big Freeze or Big Rip as the most probable, depending on the behavior of dark energy. However, its nature remains one of the greatest mysteries in cosmology, and our understanding of the universe is far from complete. New discoveries could radically change our view of the cosmic fate. Regardless of which model ultimately proves correct, one thing is certain: the universe won't last forever. But exploring these scenarios helps us reflect not only on the future of the cosmos but also on our place within it, sparking a sense of wonder and curiosity that will continue to drive us toward new discoveries. What do you think of these scenarios? Let us know in the comments, leave a like, and subscribe to the channel.